the roots of a quadratic function. In this video, we'll compare the graph of a quadratic function to the solutions of a quadratic equation, and we'll determine when a quadratic equation has no real solutions.
I have the graph of f of x equals x squared plus 6x plus 5. There's 4 points marked in gray on this graph. One is the y-intercept, which goes through 0, 5. That point can be found by evaluating the function at x equals 0. And you can see that 0 makes all the x terms disappear and only leaves the constant term 5. That's a point that's easy to find, but it's not as important as the x-intercepts, which are called the roots of the function. The roots are negative 5, 0, and negative 1, 0, and they come from solutions to the quadratic equation 0 equal x squared plus 6x plus 5, because that's when y equals 0. X squared plus 6x plus 5 is factorable. It factors to x plus 5 times x plus 1, so those are the solutions. X plus 5 equals 0 gives me the solution x equals negative 5. And x plus 1 equals 0 gives me the solution x equals negative 1. Finally, we have the vertex. Now the vertex, because the parabola is symmetric, comes right in between the two roots, exactly at the midpoint. So another way to find the vertex is to use the midpoint formula, and we would find that the x-coordinate of the midpoint is negative 3. Now the y-coordinate is of course 0, and that's not the coordinate of the vertex. To find the coordinate of the vertex, we evaluate the function at negative 3. That gives me is equal to negative 4. So the vertex is at negative 3, negative 4. Well, let's look back at these points. I found the y-intercept by evaluating the function when x equals 0. I found the roots by solving the quadratic equation and getting two roots, which are the places where the graph goes through the x-axis. And I found the vertex a new way. I found the midpoint of the two roots to find the x-coordinate, and then I evaluated the function at that x-coordinate to give me the vertex. Let's look at the graph of f of x equals negative 2x squared minus 3x plus 1. Notice that since the coefficient of the x squared term is negative, the parabola opens downward. The y-intercept is right here. It's found by evaluating the function when x equals 0, but since we know that the 0 makes the x terms cancel out, I can just look at the constant term and write the coordinate. It's at 0, 1. If I want to find the roots, which don't look like they're at whole numbers, I need to solve the quadratic equation. Well, this quadratic isn't factorable, so I'm going to use the quadratic formula. It's 3 plus or minus the square root of 17 over negative 4. Well, it's nice to have the exact value, but we also might want a decimal approximation. So let's do that. I'm going to use my calculator to evaluate the two solutions. And I want you to be careful with the calculator. When you're evaluating, you have to evaluate the numerator first, either with parentheses or by pressing enter. If you don't, you get a different answer. The first one here is done correctly. There's parentheses around the numerator, but the second one, the calculator interprets this as you asking to add 3 to the division of the square root of 17 by negative 4, because it's using the correct order of operations. So you see that you get two different answers. The top one is correct. So 3 plus the square root of 17 over negative 4 is about negative 1.78. That looks like it's this point right here. X is negative 1.78 and y is 0. Try the second one on your calculator to make sure you know how to do it. You should get 0.28, and that looks right on the graph, 0.28, comma 0. The last point we want to consider is the vertex. So there's a couple different ways to find the vertex. One way that's not very popular with students is to complete the square, to put the function in vertex form. So then I could read the vertex hk from the function. Another way is to use the formula negative b over 2a to find the x-coordinate, and then you can evaluate the function to find the y-coordinate. Let's try that one. Negative 3/4. Does that look right in this picture? Well, yeah. If I evaluate the function at negative 3/4, I get 17/8, which is 2 1/8. And again, I see that that looks great on the graph. So 17/8 is the y-coordinate of the vertex. Now the third way, of course, is to find the midpoint of the two roots. Then I can evaluate as before. Let's talk about the graph of f of x equals x squared plus 4x plus 7. The y-intercept is 7 because that's the constant term, and 0 makes the x terms cancel out. The vertex has an x-coordinate of negative 2. That's because the x-coordinate is at negative b over 2a, and b is 4, and a is 1. Well, negative 2 is the x-coordinate, and the y-coordinate is f of negative 2 is 3. So that looks right here on the graph. But the question is, what are the roots? The graph doesn't go through the x-axis. There are no x-intercepts. If I use the quadratic formula to find the roots, I find that I have a negative inside the square root. And that means there are no real roots, only complex roots. So if the function has no real roots, the graph has no x-intercepts. If I look at the quadratic formula, the part inside the square root, b squared minus 4ac, is called the discriminant. It's called that because it discriminates between real and complex solutions. If it's greater than 0, there are real roots and x-intercepts for the graph. If b squared minus 4ac is less than 0, the roots are complex and the graph has no x-intercepts. The last graph I want to show you is the graph of a perfect square quadratic. X squared plus 6x plus 9 factors. It's x plus 3 times x plus 3, or x plus 3 squared. So the only root of this equation, 0 equal x squared plus 6x plus 9, is when x equal negative 3. The graph only goes through the x-axis in one place, at x equals negative 3. And the only way that can happen is if that's the vertex. The x-coordinate of the vertex, using the formula negative b over 2a, is negative 3, and the y-coordinate is 0.
To summarize, the graph of a quadratic function is a parabola. The graph goes through the x-axis at places where y equals 0. These are called the roots of the function. The vertex of the parabola is halfway between the two roots. And the vertex is either the highest or the lowest point of the parabola. If the discriminant of the quadratic formula b squared minus 4ac inside the square root is negative, the function has no real roots, and the graph is either entirely above or entirely below the x-axis.